All right, in this lesson, we are studying trigonometry. And trigonometry is a relationship between lines and angles. What do we mean by lines and angles? You will see here, I have a triangle that is called a right-angled triangle. So we're going to name this triangle A, B, C. All right. So it's a right angle triangle because of the square at the center, meaning it makes an angle of 90 degrees. Okay, what are the lines here? We have three lines actually. So this line AB, or we can also call it line small letter A because it is facing the bigger A. So this is also OA. We also have line AC, which we can also refer to it as line small letter B, giving it small letter B because it's facing the capital letter B. And the third line is line BC. Here, line BC, which we can also refer to it as line small letter C because it is facing the capital letter C. So these are the three lines of our triangle ABC. How about the angles? So the angles are these areas inside here. We've already spoken about the first angle B, which is a 90 degrees, hence we call this a right angle triangle. We also have angle A, we also have angle C. But at this stage, we're not concerned with angle B because we already know its magnitude. So we're going to check the relationship of angle A and angle C in relation to lines AB, lines AC, as well as line BC. So what angles do we have here? The first angle, we can refer to it as angle BAC. So we have angle BAC. Notice that little head on top of A. So that means it is the letter that is between BC. So we are in angle BAC. The second angle will then be angle ACB. Angle ACB. All right. So now we're going to check the relationship. So let's now focus on one angle at the time. There are three sides to a triangle. We look at the opposite side. We look at the adjacent side as well as the hypotenuse side. So let's start with hypotenuse. The hypotenuse side is the longest side on the triangle, the one always facing the 90-degree angle. Okay. So the side that is facing the 90-degree angle, that's the side that we always refer to as a hypotenuse angle. Okay. So whether the angle we are referring to is BAC or BCA, that side that is facing 90 degrees will always be called hypotenuse. So now let's focus on angle BAC. So the hypotenuse of BAC is AC. The hypotenuse side of BAC is side AC. What would be the opposite side to angle BAC? It is the side that is directly opposite it. So angle A is opposite side BC. And then what would be the adjacent side? It's the side that is right next to it. So angle A is adjacent to side AB. So let's go to angle ACB. Okay, what would be the hypotenuse side of side A of angle ACB? It's always, hypotenuse is always that side that is opposite the 90-degree angle. So just like angle BAC, the hypotenuse of this also will be side AC. What would be opposite side of angle ACB? It's opposite to side AB. And then the adjacent side, the side right next to it, the adjacent side of angle ACB, this angle over here, will then be BC. All right. So now that we know what angles are and what lines are, what is then the relationship? Okay. So we relate these angles, we relate these sides with what we call trigonometric functions. These trigonometric functions are referred to as sine, cosine, as well as tangent. So the relationship, we're simply going to refer to it as a SOHCAHTOA. So this means that the sine will be a ratio of an opposite side over the hypotenuse side. A cosine will be a ratio of an adjacent side over a hypotenuse side, while the tangent will be a ratio of an opposite side over adjacent. Let's have an example. Okay, now we are doing angle, the relationship between angle BAC and its sides. All right. So starting with sine, we know that sine BAC will be equals to the opposite side of that BAC over its hypotenuse side. So BAC is this angle over here. Its opposite side is BC. Hypotenuse is always the side that is facing the 90-degree angle, and its adjacent side will be side BC. So that means the sine of BAC will be equals to opposite, which is BC, over the hypotenuse, which is AC. The cos of BAC will then be equals to, we said it's CA, which is adjacent over hypotenuse. So what is the adjacent of BAC there? It's side AB. All over hypotenuse, which is still AC. Okay. So now the focus is angle ACB. Angle ACB. This angle here. Let's determine the side. The one that is opposite our 90-degree angle, we refer to it as a hypotenuse. What's opposite C? It's that side AB. And what is adjacent to it? It's the side BC. Okay, let's start with sine. So sine of ACB will be the opposite side over the hypotenuse side. What's opposite? Here, it's AB. And then what's the hypotenuse? AC. And then now, what would be the cos of angle ACB? Okay, opposite cos is the adjacent over the hypotenuse, which is the adjacent side is BC, over side hypotenuse, which is AC. And lastly, the tangent of angle ACB. We know tangent is opposite over adjacent. So the opposite of this angle is AB. And the adjacent side of it is BC. Okay, still on trigonometry. So now we're going to do the reciprocal of the ratios that we just did, which is sine, cosine, as well as a tangent. All right. So if you remember, we said sine would be an opposite side over the hypotenuse. So what is a reciprocal of this sine? Let's have a theta over them. The reciprocal of the sine ratio is called cosec theta. Okay, this we can refer to it as 1 over sine of theta. So what then happens when you get a ratio, a reciprocal of a ratio, is that it actually swaps the denominator with the numerator and the numerator with the denominator. What that means now, it means a cosec theta then becomes a hypotenuse side over the opposite side. Okay, so if your sine was to be 2 over 5, that means the cosec would be 5 over 2. All right, how about cos? So we have cos of theta, which we know to be the adjacent side over the hypotenuse, and then we call its reciprocal ratio a sec theta. This we can refer to it as 1 over cos theta, and then the ratio will then be the hypotenuse side over the adjacent side. And the last ratio that we know is the tangent of theta, which we know to be the opposite side over the adjacent side. So the reciprocal ratio of this is called cot of theta, which is 1 over tangent theta. So what are the sides? The sides will then be the adjacent side over the opposite side. Okay, so these we refer to them as the reciprocal ratios of sine, cos, as well as the tangent ratios. So we have cosec for sine, we have sec for cos, and we have cot for tangent. And then remember, it just means we make the denominator the numerator the denominator. All right. So now, another important thing is what we call the Pythagoras theorem. The Pythagoras theorem will help us to always get the missing side. And it only applies on a right angle triangle. We call it Pythagoras theorem. Okay, this theorem can only be applied on a right angle triangle. What does the theorem say? We take the hypotenuse side, which is the longest side of the triangle, facing a 90-degree angle. We say AC squared will be equals to the sum square of the other sides. So that would be AB squared plus BC squared. Okay, so if we have two sides, using this theorem, we can find the remaining side. Okay, so we can make AB subject of the formula, which can then be AB equals to the square root of AC minus BC squared. Or we can find BC, which is then the square root of AC squared minus AB squared. So this is going to come in handy when we have a side missing. All right, so if you remember, one of the principles of a triangle is that if you sum up all the angles of a triangle, they equals to 180. So that means angle BAC plus angle BCA plus angle B all equals to 180. So now this means that we can represent this angle in terms of the 90-degree angle. Okay, so I can make BAC subject of the formula by saying BAC is equals to, okay, before that, remember that we have ABC, which is the right angled triangle equaling 90 degrees. So from this, we can then make BAC a subject of the formula in representation of 90 degrees. So we can then say angle BAC is equals to 180 minus 90, that is 90. Then we say minus angle BCA. Likewise, we can say angle BCA is equals to 180 minus 90 will give us 90 minus angle BAC. So this angle here, BCA, is equals to this 90 minus the other angle, which is BAC. And angle A here, or BAC, is equals to this 90 minus the other angle, which is BCA. So here's a question or an exercise. You are given that cos x is equals to 3 over 4, and that x is between 0 and 90 degrees. We need to determine the tangent of x. Okay, what do we know? We know that cos of x, that's a k, would be equals to the adjacent side over the hypotenuse side. So this gives us that the adjacent side is now the magnitude 3, while the hypotenuse side is equals to 4. So we can draw our triangle. Remember, a right angle triangle. So let's have it here. And then remember now this angle x, we can either place it here or there. It doesn't matter so long as it's not on the 90 there. So let's say it's here. Okay, so what is adjacent to this angle x? It's going to be this side over here, which is given to be 3. And then what is hypotenuse? Always the side facing the 90-degree angle. So this is 4. So now we have a side missing. That is the opposite side. So that means, and we're not able to find the tangent without that opposite side. So we need to find the opposite side. So we know now that we can use a Pythagoras theorem because this is a right angle triangle. All right. How do we find this? So this opposite side will then give us the square root of 4 squared minus 3 squared. Where do we take this? Remember the theorem of Pythagoras says the hypotenuse side squared will be equals to the opposite squared plus the adjacent squared. The longest side squared is always equals to the sum of the square of the other two sides. And then we just made opposite subject of the formula. So this would give us 16 minus 9, which is equals to square root of 7. All right. So now we have the opposite side, we have the adjacent side, and we have the hypotenuse side. What would then be tangent of x? The tangent of x, we know it's the opposite side over the adjacent side, 2. So the opposite was, we just found it to be square root of 7, and then we know the adjacent side, which was given, it's 3.